Welcome back. This is the third in our short series of lessons on algorithms to find the shortest route from a start to an end point. In this lesson, we'll learn a new algorithm called the A-star algorithm. In this lesson, we'll look back at how the Dijkstra algorithm works and think about any problems that arise when we use Dijkstra to find the shortest path. We'll think about how heuristics can help to improve Dijkstra, and we'll look at the A-star algorithm, which adds a heuristic to Dijkstra to work more efficiently. So let's think back to how Dijkstra works. At each stage, we calculate the total distance to each node from the start node. We then choose the node where the total distance from the start is the smallest, and that becomes the next active node. The algorithm is what we call a greedy algorithm. It picks the best answer at that point. It doesn't look ahead. It just looks for the shortest distance each time. And that could be in any direction. So you could be heading in completely the wrong direction. The computer wouldn't know. You just keep calculating these short routes until one of the short routes happens to hit the target node. That means that Dijkstra wastes time exploring paths that go in the wrong direction. And when you were doing Dijkstra, you might have noticed that you had to calculate rows of the table, even though you could see very clearly that those were not the right routes. You could see it because you were standing outside of the problem, looking at the whole picture and using your common sense. Those are things that a computer can't do. So Dijkstra ended up wasting time exploring routes that were not helpful. People wanted to find an algorithm that avoided this problem. And interestingly, a key audience for an improved route finding algorithm was the computer game industry, because people didn't want to waste time while they were playing computer games with the sprites or the enemies or the monsters slowly finding their way through a maze or a dungeon, going in the wrong direction. They wanted the computer's characters to go quickly and efficiently to the right location so they could engage in the game, just like a person can. So the decision was made to improve Dijkstra by adding a heuristic. Now, I asked you last time to think about what a heuristic was, so let's just recap what a heuristic is. A heuristic is an estimate. It's not necessarily fully accurate, it's just good enough to give us a quick answer. So we're going to improve Dijkstra by adding a heuristic that gets us to pick the correct routes to get to the target, the place that we want to get to, as quickly as possible. The A-star heuristic, as it is called, tells us the distance to the end point. It's only an estimate. Of course it's only an estimate because we haven't done the full algorithm yet. We haven't actually got the right route, but we make a good guess at the right location. We add this guess to the known distance that we've already calculated, and that gives us something called the A-star total. We only use the A-star total once each round, at the point when we need to choose the next active node. In Dijkstra, we choose the node that is closest to the start. But with A-star, we choose the node that is close to the start and close to the end. And that eliminates all these random routes going off in the wrong direction. The A-star algorithm will only work if we've got a good heuristic. And if we can't get a good heuristic, then we can't do A-star. It just won't work. But here are some ways that we could end up with a good heuristic. Even though we may not know the right road to take, we might know the distance as the crow flies, as we call it. A satellite might be able to tell us that. Or if we're running a computer game, we could use the XY coordinates that set the position of where we're trying to get to. Or if we're working on a map, we might use latitude or longitude. For instance, if we were going from, let's say, London to Edinburgh, we would know that we wanted to be heading in a northerly direction. These are just some examples. So let's recap how A-star works. We add together the Dijkstra value, which is the distance from the start, with an extra heuristic, which estimates how near we are to our target. And we use this A-star total to choose our next active node. Apart from that one point when we're choosing the active node, we do everything just the same as Dijkstra. But by adding that extra stage, it stops us going off on odd routes that are taking us in the wrong direction. So it's worth thinking here, what is the advantage of the A-star algorithm? The A-star algorithm does not find a better route than Dijkstra. It doesn't find a shorter route than Dijkstra. Both A-star and Dijkstra find the same route because there is a best route. If you were going from Nuneaton to London, there's a best way to do it. And it doesn't matter which algorithm you use, both algorithms would find the same route. But A-star finds the route with less calculation, so you get the result quicker. It's the same result, you just get it a bit more quickly. So you could set this out in an advantage-disadvantage table like this. Both algorithms find the same route. A-star finds it more quickly, but it needs a heuristic, whereas Dijkstra takes longer to find the right route, but you can run Dijkstra even if you don't have a heuristic. That's it. So do be careful in the exam. Don't say A-star finds a quicker route. That's the wrong way of putting it. Instead, we say A-star finds the route more quickly. It's less processing. So to demonstrate this to you, we're going to do a Dijkstra activity. This is a chance to recap your Dijkstra skills. I'll show you a graph and you're going to use Dijkstra. So here's the graph. The circles here represent the cities of Europe, but I've just replaced the names with letters to make it easier. And you can see that just as in real life, there are all routes going in all directions, and you've got to find the quickest route from D to J. I said before that a person can judge routes better by eye than a computer can because we've got the big picture, and I expect you can easily see the right route here, D, E, H, J. However, if you do Dijkstra, you'll end up having to check all the routes that go in all the different directions. So we're going to do that. This has got two reasons. One is it's good practice with Dijkstra, and the other is you'll see how much quicker it is to use A-star, which is what we're going to do next lesson. Okay, so if you're my student, I'm going to give you a printed sheet with this so that you can do it easily by hand. But in any case, have a go at this. Rejoin me next lesson to see the answers to this exercise and to redo the whole thing much more quickly using A-star. Bye for now.